Hi, good afternoon to all the participants. I want to welcome Dr. Seema Sipat. Ma'am is Senior Scientist, ICR, Indian Institute of Maize Research, Ludhiana, Punjab. And the topic chosen for deliberation today is improved agronomic package of practices for silage maize production. Now, let me introduce first Dr. Pratiksha, who is going to provide the introduction of Dr. Seema. Dr. Pratiksha, you can start.
Good afternoon, all. I welcome you all again for the afternoon session. And the lecture will be given by Dr. Seema Sepat. She is working as senior scientist in ICAR, Indian Institute of Maize Research, Ludhiana, Punjab. Dr. Seema Sepat qualified ICAR JRF for the master's degree program and completed her MSc in agronomy from ICAR IARI, New Delhi. Dr. Sepat was awarded Senior Research Fellowship during her PhD program in agronomy at ICAR IARI again. In the year 2009, Dr. Sepat started her career as scientist on 15th of December 2009 at ICAR IARI, New Delhi. She has been involved in research, teaching, and extension activities in agronomy for the last 15 years. Dr. Sepat was awarded the prestigious Borlaug Fellowship in 2015 at Louisiana State University, USA. Dr. Sepat was the recipient of the Associate Fellow of Indian Society of Agronomy, New Delhi, the Best Young Scientist Award from ICAR IIMR, Ludhiana, and Sri Ram Purashkar from Fertilizer Association of India in 2016. She has supervised 8 MSc and 5 PhD students as a major advisor and is a member of the advisory committee of more than 15 MSc and PhD students. Her two master's students received the Best Thesis Award from ISA New Delhi. Dr. Sepat has published 45 research papers, 60 popular articles, 11 book chapters, and 3 practical manuals. She has the credits for various editorial assignments and manuscripts reviewing for both national and international journals. Dr. Sepat has also conducted seminars, workshops, and brainstorming sessions and worked as the expert in various summer winter school training courses for academician and research sector personnel. Ma'am, I welcome you for today's session. You can share your valuable insights with us.
Thank you. Thank you, Pratiksha. Let us start with today's topic, that is the improved agronomic package of practices for silage maize production. You know, there are three things has been covered in my topic, and I tried my best to elaborate everything in detail. First thing, I will talk about the maize, why maize is so much important crop. And second one is what kind of agronomic package of practices we can include to improve the productivity of maize. And third one is the silage. Silage, I think most of the participants know that silage is used for animal production, right? To feed them quality fodder. It's known as a quality fodder, and it is used just to enhance the milk production of animals. So basically, my seminar today covered three topics. So let us talk about the maize, why maize is so much important crop in coming years. First of all, we all know that maize is the third most important crop of India, and it's placed third after rice and wheat. And it's a very versatile crop. If you see the uses of maize, you will astonished to know that it is not only used as a cattle feed, it's not used as a direct consumption where we use it as a food, but rather than food, feed, it's mainly goes into the poultry sector, you know, as a feed. And another area which is coming of maize utilization, that is the starch production. If you see the pie chart, you can see that in poultry sector, around 47% of whatever we produce, we consume in the poultry sector. Out of this, 20% as a direct consumption in terms of the chapati or cornflakes and etc., etc. Various byproducts are there which we are consuming in our day-to-day life. 14% of the produced maize is used as a cattle feed in terms of the fodder, in terms of the silage, and various aspects are there, and 12% as a starch. Why starch is so important nowadays? Because starch is industrial product. You know, it's used mainly in the producing paper, and now government of India has set a goal that in 2025 petrol blending of petrol is need to be done with ethanol. So maize is very rich in starch, and if starch content in any crop is high, which can produce abundant amount of ethanol. That's why the importance of maize is now emerging. And another one is the food and beverages and others, in which pharmaceuticals, varnishing industry comes, where the produced amount utilization is 7%. So this is basically the distribution pattern of maize production, that whatever we are producing, the total amount of production, how it goes into the various sector. As I told you that in 2025, Government of India has set and target that petrol should be blended with 20% ethanol, and this ethanol is produced from the maize. Why? Because of the starch content. This starch would be converted into the ethanol. So besides poultry sector, and bioethanol production from maize has generated an additional demand of 17 million tons by 2025. We are now short of the maize grain because of this bioethanol production target set by the government of India. Besides this, its importance, another second area which is emerging is the silage. Why? Because this is most suitable crop for silage production, besides pulse millet and other crops. Why this is so much attractive crop for silage production? Because maize is the high yielding crop with less infestation of weed, pest and diseases. You might have heard that maize is known as the queen of cereals. Why queen of cereals? Because it has the highest yield potential among the cereal. Remember it, that whatever rice and wheat crops are there, whatever they are producing, rice productivity is around 3.5 and wheat around 4 ton per hectare. But maize, being as a C4 plant, has the highest yield potential among the cereals. So based on these attributes, this is very good crop for silage production. And in northern India, mostly in Punjab and Haryana regions, cultivation of spring maize is coming nowadays like anything. We know that maize is cultivated in 3 seasons, mostly all over the India. It's a Kharif season. The area under Kharif season is very high, followed by your Rabi maize and then the spring maize. But now reverse trend we are seeing that the spring maize cultivation is coming in very vast area, mostly in the Punjab and Haryana. Spring maize means date of sowing, date of month of sowing is February, in the month of the February. So the span or the niche area for silage production is Punjab and Haryana. And spring crop means there is a less infestation of insect, pest and diseases. Secondly, weather is also favorable because during the spring season, silage crop is harvested, and weather is somewhat more favorable for spring season maize, right? Another aspect is that this energy crop has proven suitability for silage because of the low buffering capacity and high water soluble carbohydrates. This crop is very much rich in carbohydrates, and protein content is less, as we know that cereals are rich, abundant source of carbohydrates. And low buffering capacity means whatever changes in the pH is during the silage making process, pH should be the constant. So less changes are noticed when we use the maize as a silage crop. Okay. Another one, there are two aspects are there, that legume inclusion with maize for silage in an excellent blend, as maize supplies carbohydrates and as an adequate substrate for lactic acid bacteria to proliferate, thereby assuring quality fermentation owing to high protein content. There are two aspects. Either we have only maize crop, but maize silage produced through the use of only maize, then it will be rich only in carbohydrates. There is a lack of protein. But if we include legume during the silage process, silage making process, then there are chances that the carbohydrate and protein need of animal can be met through such kind of silage. So that's why I'm giving an emphasis here in this slide that maize along with legume can be a best option. And how we'll do it, I will elaborate in the coming slides. Like maize intercropped with legume, silage is rich in protein and vitamins, right? But prone to spoilage. If we include excessive amount of legume, then what will happen, that it will spoil within a short period of time. And most of you all know that we know that there are two things, that production of butyric acid and second one is production of lactic acid. In this, butyric acid is undesirable. Why? Because it produces the awful smell, and there are chances that animal will not like it. So production of butyric acid is undesirable, but if we include the legumes, then there are chances that the production of butyric acid will be high. Second acid is lactic acid, which is very desirable. It has a pleasant odor and have a high digestibility among the animal also. Production of lactic acid is desirable, but the production of butyric acid is undesirable. There are two things during the making of silage, right? Silage produced through intercropping. Intercropping, I think most of all of you know that growing two crops simultaneously on the same place and at the same time is known as intercropping. Their ratio can vary, but India, we follow the additive series. You know, there are two series, additive series and replacement series. Additive series means base population. Like if you're taking the maize and legume, maize is our base crop. So population of maize is maintained at the same space, but additional crop is what here? Legume is added into the maize. So base population will remain the same. Base population of maize will remain the same, but additional lines of legume are added. And on the contrary, replacement is series, 50-50% of population of both the things are maintained. Like if maize is coming at 50% population, means if there are 2 rows of maize, then the 2 rows of legume will also maintained at the same place. But in India, we do not follow the replacement series. We follow the additive series. Means we try to accommodate additional rows of legume in maize. So most of the findings indicated that silage produced through intercropping, like having 60% millets and 40% pulse recorded high silage yield, lactic acid, crude protein, and lesser amount of acid and neutral detergent fiber. There are certain things most of the veterinary people know what is crude protein and neutral detergent fiber, and why protein is desirable to make the muscles and production of milk, while neutral detergent fiber are need to be at lower amount, because fiber is desirable but not at that rate. So if we take the right proportion of maize and legume, then it will produce high silage yield, and production of lactic acid and crude protein will be higher. But there are chances that at farmers' field, a consolidated information on maize intercrop with millets at various row proportion and it impacts on biomass yield and silage quality is lacking. Lot of research is needed because at farmers' field also and at farmers end only maize is used as a silage, but efforts should be made that maize and inclusion of legume should be there for making the silage production. So coming to the variety selection, there are certain agronomic package of practices are there in which it includes the variety selection. Variety selection means we should include those varieties which are high yielding in terms of the biomass, means the cob and the forage, it should be at the higher side, and plant should be at good architect, high dry matter content should be there, and the varieties of maize should be resistant to disease, because we cannot recommend or we cannot spray a lot pesticide into the forage crop, because whatever pesticide we will spray, it will end at the animal, and we don't want such kind of things. So option is there that we should select such kind of varieties which are naturally resistant to disease, and additionally this should suit to the climate. Choose the varieties according to your climate. Like if the climate is hot and dry, several varieties are there, and if the climate, when we know that the chances of this disease incidence are high, they choose the varieties accordingly. There are certain varieties which are very suitable for silage making, that is DHM 113, DHM 111, DHM 117, Pro 311, and varieties produced from the PAU, that are the PMH 13, PMH 9, PMH 3, and high quality protein maize are also there, and varieties from the private sectors are also there, like Pro 311, CP 838, and DKC 908. In Punjab and Haryana, preference on these three varieties are high, like CP 838 and DKC 9081. They are from the Adventa, and another one is the from I don't remember, but these two varieties are mostly used for silage production in Punjab and Haryana. After the selection of variety, second thing which comes is the soil preparation and nutrient management. Okay, so it is necessary that for maize production, slightly neutral soil are preferable. Means the pH should be the around 6 to 7, because this neutral pH is not acidic and not too much alkaline, because these two conditions are unfavorable for maize production, right? And soil should be free from waterlogging situations, waterlogging where the water stagnates. So such kind of situation should be avoided, because maize is very much sensitive to waterlogging condition. If water stands for 24 hours, more than 24 hours in the field, then the maize crop will ultimately die. There are no chances that it will survive. So soil should be free from the waterlogging condition. And how to prepare the soil? Give 4 to 5 plowing and planking based on the implements which are available at the farmers or at the consumer end, and make the seed bed free from clods and weeds. And before applying nutrient into the crop, it is necessary that before sowing, soil samples should be collected and they should be determined for nutrient levels. Like if they are low in nitrogen, phosphorus, and potassium, these three basic elements should be analyzed into the soil. And suppose if soil is towards the alkaline side, then the gypsum should be applied. In northern parts of the country and mostly in the southern part, acidic soils are not available. These are available. These sites are available on the northern eastern India, So in northern side, alkalinity is there, then the gypsum should be applied to the soil. And FYM or a compost, if they are available, they should be applied before 1 month in advance, well in advance. And whatever NPK nutrient recommendations we are making the maize, they should be in the balanced proportion. There are, and most of you know the balanced proportion is the what is that? 4:1, 4:3:2, 4:3:1 means whatever proportion is there, NPK should follow that ratio. In maize, it is recommended that irrespective of soil fertility, that the nitrogen should be around 120 kg nitrogen per hectare. Phosphorus is around 60 kg nitrogen per hectare, and potassium is 40 kg per hectare. 40 kg per hectare. If suppose the soil are very poor, then the dose can be increased slightly 20%. It can go up to 150, 80, 60 if the soils are poor. But this ratio should be maintained. And maize is also a crop which is very sensitive to zinc deficiency, and maize is also known as a zinc indicator plant for zinc. If suppose zinc deficiency is there, among the most of the crop, maize is the crop which will indicate the deficiency symptoms of zinc at first, right? That's why it's known as an indicator plant. If zinc deficiency is there, then it should be corrected at the time of sowing. Zinc application is done through the soil application method, because zinc can be applied through the spray also, but the most effective mode is soil application. So wherever zinc deficiency is there, apply 25 kg zinc per hectare. There are two forms, zinc sulfate heptahydrate and zinc sulfate monohydrate. If it is zinc sulfate heptahydrate, then it is 25 kg per hectare, and if it is monohydrate, then the dose is 20 kg per hectare, because zinc monohydrate form is more concentrated form of zinc, right? Second thing is the planting practices. What kind of planting practices we can follow to optimize the maize yield? So as I told you, silage is most preferably grown during the spring season, and spring season starts from 20th January to 15th of February. So this period is most suitable for spring maize. Why I am not talking here Kharif and Rabi maize? Because Rabi maize is not preferable for silage production. Why? Because if you see, Rabi maize has the highest yield potential. Why? Because it's a long duration, and there is temperature fluctuation is very less during the Rabi season, means winter season. And winter season maize is grown in Bihar region, and whatever maize is produced during Rabi is mostly used for poultry consumption, because it is free from fungus infestation. Likewise, in Kharif, whatever maize is produced is used for the grain consumption purpose. But during the spring season, it is the shortest season, because temperature is high, so crop matures very fast. And spring season means this. If you see this window, most of the field, if suppose someone is taking potato or an other crop except the wheat, then this window remains empty. So farmer most preferably grow spring maize, because afterwards lean season will start, means scarcity of fodder will be there. So whatever spring maize is produced, it can be converted for the lean periods, which are May to June. During this lean period, silage is produced, and it is ultimately used for the animal consumption. Remember one thing, that the crop should be sown on the southern slope or east-west ridges, where the direct sunlight of sun is there, because this crop, as I told you earlier also, that maize has the high yield potential, and to optimize the solar radiation, it should be sown to the parallel of sun direction, which is the east to west direction. Seed rate is 10 kg seed per hectare. There is no difference between the fodder maize or grain maize. So seed rate will remain the same, and all the management practices will remain the same. So seed rate is 10 kg seed per hectare, and to control incidence of pest and diseases, seed treatment is the best option. And for seed treatment, guacho, that is the imidacloprid, it should be used 6 ml per kg of maize seed, right? And then the proper planting density. Maize is sown mostly at the 60 centimeter row to row distance and 20 centimeter plant to plant density, right? It's a wide spaced plant and should be sown at 16 to 20 centimeter plant spacing to optimize the population density. If you see nowadays, new techniques are coming, new machine are coming, and the place where I'm sitting, there is the Punjab, where farming is fully mechanized as compared to other states of India. If you see, this is called as a broad bed planting. It is done by the pneumatic planter, which is a machine in which the rows of plant to plant is 90 centimeter, right? 60 centimeter, and bed width is 90 centimeter. So mechanization of maize is necessary to reduce the labor requirement and to reduce the time also. So that's what my purpose, that the new techniques are available, new machineries are available on which sophisticated sowing of maize can be done. And I'm not going into the detail. There are several aspects also there. Coming to the irrigation management, that irrigation is very crucial for maize. As I told you earlier also, that maize is very sensitive to waterlogging condition. If water stays for too long, then the maize will die. And if water scarcity also occurs, then maize is very sensitive. It will produce shrink grain. So irrigation management is very crucial. And there are certain crucial stages, critical stages, which are very sensitive to irrigation that should be managed accordingly. Like ensure proper irrigation at the time of sowing. Then the critical is a knee-high stage, which comes after 35 days after sowing. Then the tillering, silking stage, which comes at depending on the variety, but it mostly comes at the 55 or 65 days after sowing. If it is long duration variety, then it is delayed by 1 or 2 days. So at these stages, irrigation should be certain, and at the time of grain filling stage. But in overall, in maize, silking is the most sensitive stage where management of water is required. Irrigation mostly required. So ensure we need to ensure adequate water supply during tasseling, silking, and grain filling stage, right? These stages are maintained and abundant amount of water is applied, then there are chances that the yield would be high. In maize, remember, 2 things are very important in any crop, irrespective of maize. That first, you need to focus on fertilizer, and second aspect is irrigation. If these 2 aspects are well covered in any of the crop, then what will happen? Then the yield potential, the yield productivity of crop certainly will be high. So these 2 elements are very critical. First one is the fertilizer, second one is the irrigation. Now coming to zinc deficiency, if you see in the insect picture, that zinc deficiency, when the white and yellow stripes develop on the plant, then we can identify that is these are the symptoms of the zinc. And zinc deficiency comes at early stage. It is not like that it will come after later on. So symptoms appear within 2 weeks of seedling emergence, and uh, a broad band of white or very light yellow tissues in between the veins appear in the midribs also. And zinc deficiency comes in between, like not on the newer leaves and not on the older leaves, because it's slightly immobile in the plant. It's not like nitrogen that highly mobile in plant and the deficiency symptom will appear on the lower leaves. This is slightly immobile. So second or third leaf from the top of the plant, the symptoms would appear. So these 2-3 things are there, how to differentiate between the nitrogen deficiency and between the zinc deficiency. Okay, as I told you, if heptahydrate form is there, then 10 kg per hectare, and if you convert as a hectare, then it's a 25 kg zinc sulfate heptahydrate should be applied at the time of sowing, right? Not after the sowing. And certain things are also there, like zinc response are better when it's applied with the unslacked lime, right? Lime and zinc have an additive effect on crop. So whatever zinc form is there, either it's heptahydrate and monohydrate, it should be mixed into the unslacked lime, not the slacked lime, right? And the quantity is mentioned, that how to spray if instead of soil broadcasting, if you want to spray on the crop, then the amount is mentioned. It should be mixed with the unslacked lime, then it should be used for the broadcasting. Okay? Then the pest and disease management. In incidence of pest and disease in maize is influenced by the season. Rabi is the most favorable season when the chances of disease and pest incidence is minimal. Why? Because in Rabi, this inoculum of pest and disease is increased when the temperature is high and humidity is high. Such kind of situation occur during the Kharif season. So among the 3 seasons, Kharif season maize is very prone to pest and disease infestation, but the spring, spring season maize is infested by fall. You must have heard fall armyworm. It's a very dangerous pest of maize, but in Rabi season, the incidence of these diseases are less. So let's talk about the most serious disease of maize. In maize, insects are more important. And in insect also, only 2 insects are more important. And in the disease also, only one disease is important, that is the banded leaf and sheath blight. You might have seen the maize with these necrotic spots on the leaves or on the stem. So it is known as the banded leaf and sheath blight. To control this, Amistar top pesticide is there, which can be sprayed 100 ml dissolved in 200 liter of water per hectare. So, but spray pesticide when it is needed, right? Not based on the, like if these symptoms are visible only on 1 or 2 plants, then there is no need to spray pesticide, because this crop would be used for silage production, right? And too much use of pesticide should be avoided for making the silage. Like among the pests and diseases, weeds are also very important. And maize is a wide spaced crop. It is sown at 60 to 20 centimeter row spacing. So, and initially up to 45 days after sowing, the growth of maize crop is very slow. And then if open space is there in the field, then there are chances that the germination of weed is high. So up to 35 or 45 days after sowing, there are chances that weed infestation is high, and we need to control up to this stage. So what kind of management practices we should follow? Like I have selected 4 herbicides, in which if you see the trade name, it is Momoji, and the commercial name, chemical name is pyroxasulfan. it should be used at the 127 gram per acre, right? And it should be applied 1 or 2 days after sowing. Another alternative you might have heard that in maize, the most common herbicide is atrazine, which is known as, the trade name is Atratraf. So 1 kg per hectare, depending on the soil type, the dose will vary. But in general, 1 kg per hectare is recommended for atrazine. And another alternative of pre-emergence herbicide is pyroxasulfone, trade name is Momoji, and the dose is very low, 127 gram per acre. These two pre-emergence herbicides are excellent herbicide for maize. They will control the weed up to 30 days. After 30 days, there is a range of herbicide which can be used. You might have heard Lodis, and it's a trade name, and the commercial name is Tembutrione, right? And it's very good herbicide, and the dose is 112, around 100 ml per acre. On the other hand, Tinger is there. The trade name is Tinger, and the chemical name is Topramazone, and the dose is 25 gram per acre. So these two post-emergence herbicide can be used. And another one is Sempra. The chemical name is halosulfuron methyl. This herbicide is very good to control the cypress infestation in maize, because in maize cypress infestation is too much, and cypress is a perennial weed. To control this herbicide, there is use of halosulfuron methyl at 67 gram per hectare is recommended, and it's very good to control cypress. And the tubers, which is the cypress is propagated by the tubers. So these tubers are ultimately killed by the application of halosulfuron. It's very selective to cypress species. Coming to the diseases, as I told you that there are two pests which are very voracious in nature, and they can kill or they can devour the whole maize within nights. First one is fall armyworm. You might have heard that this is it's not a it was introduced from the Africa 5 to 6 years back, and the young larvae feed by scraping the leaf surface. You can see in the insect also that the peppery leaves are produced. To control this fall armyworm, very good insecticide is there. That is a Coragen. Coragen is a trade name, and the chemical name is chlorantraniliprole, and the dose is 0.4 ml in 1 liter water. Dissolve 0.4 ml in 1 liter water, and in 1 acre area, around 200 liters of water is required. So accordingly make the formulations. Second best insecticide is delegate, known as the Spinotoram, and the dose is 0.5 ml in 1 liter water. Third one is the imactine benzoate, trade name is Missile, and again is dose 0.4 gram liter. So these three insecticides are very good insecticide and can control the fall armyworm. Second one is maize shoot fly. Shoot fly, and another one is maize borer, which I forgot to include here. This maize borer, what it does, that it produces dead hard. Dead hard means it feeds into the tip of the maize plant and goes downward. Up to root it will go. So it will produce a dead structure. That's why it's known as a hollow. White tip or black tip means the crop will be devastated by the infestation of borer also. And to control this borer also, because this fall armyworm and this maize stem borer, are have the larvae which feed on the plant surface. So these three herbicide, corazon, delegate, and the emactin benzoate, will act preferably good on fall armyworm as well as on the stem borer also. Then the maize shoot fly, to control this shoot fly, fluradon is recommended. The dose is 5 kg fluradon per acre. Right. So these 2-3 insects are there which are very dangerous to maize crop. Coming to third portion, that is the how to make the silage. Right. There are certain 5 stages in nutshell are there, like choice of silo. Silo means it's a structure where chopped maize is stored. Cutting and wilting the crop, at what stage you need to harvest the crop, right? After this agronomic production practices, only harvesting is remaining. So at what stage we need to harvest, at what length we need to cut, we will discuss in coming slides. Chopping the material, because in this size of cut portion varies. Then the filling and sealing the silo, how to fill and seal the silo, and then removing the silage and feeding. These 5 stages are very important in any of the silage preparation. Filling the silage is known as the ensiling. The process of filling the cut material into silo is known as the ensiling. So harvesting and ensiling we will discuss. Then the harvesting should be done when the moisture remains around 30 to 35%. The moisture should not be too much high. And if you found that the moisture is high, then cut the crop in the field and remain it for 1 or 2 days under the sun drying. Remain the crop under the sun drying. So the moisture should be around 30 to 35%. The crop should not be too much dry, and if you see, the most appropriate stage is when the maize cob have a milky grains. That would be the best stage to harvest the crop for silage. Like when you cut the material, then the material is thoroughly chopped to a preferable length, and the length is 5 to 8 centimeter. And as I told you, that maize crop should be harvested at their optimum stage of digestibility, that is the milk stage. Means if you rupture the maize grain, then some amount of grain, white thing would come out. That is known as the milky stage. Then the chop the harvested crop and pack into the silos trench. There are various structures of silos as well, but in India we prefer the trench structure. So a crop with 30 to 35% dry matter ferments into a high quality stage. If the moisture is optimum, then there are chances that the quality of silage would be high, mold and yeast infestation would be less, spoilage chances are less. That's why the moisture should be not too high or too less. Then press the chopped crop in the trench and let it remain 1 meter above ground level. There are certain stages, like if it is a trench silo, then this silo should be filled with the chopped material up to 1 meter high. Then covered it with a layer of 10 to 15 centimeter kadbi straw or wheat turi. Kadbi straw means perlite straw or wheat straw. 10 to 15 centimeter thick layer of, after filling the maize, chopped maize into the silo, 10 to 15 centimeter this straw should be covered, and again then the mud plaster need to be done on the silo trench to make it completely airtight. And thereafter a plastic sheet can be used right? And the edges should be sealed with clay and dung mixture, so the entry of air is restricted, because silage is made under the anaerobic conditions. So these 3-4 steps are there, that how to cover and at what length it should be, up to what height it should be filled into the silos. And this silage is ready within 45 days. If you make it airtight, then the silage is ready within the 45 days. And the opening also varies. That I told you in step making slide, I show you that there are 5 steps. So opening the silo pit is also necessary. If you remove the cover hole on the whole silo, then the rotting chances are very high. So only the one corner of silo need to be open, only one corner. So open the silo pit from one side only and take around 40 kgs of silage per animal. This is the amount which is recommended, that the animal should be fed with 40 kg of silage daily. And the remaining silage should be kept covered, so it will stay good in used. Do not remove the whole cover, only the portion of silo pit need to be open. And there are chances that the preserved material should have a pH of 4.5. It is desirable. Then there would be low nitrogen losses, and a good quality silage are almost retain the nutritional value of original crop and has a high lactic acid and low butyric acid content in the silage, right? As I told you, silo is a airtight structure, and it used to store and preserve the silage. And silo in India are mostly trench silos, and the optimum dimensions are also mentioned, that the silo trench having the 10-meter length, 3-meter width, and 1.5-meter depth are the ideal size for 6 to 7 to feed the 6 to 7 cows. And the dimension which I mentioned here have the capacity to store around 350 to 400 quintals of green fodder. And amount also I mentioned, that the 40 kg per animal should be feed per day to optimize the milk production. You see, local photograph I have included, that how they have covered the trench silo with the plastic, and the chopped material, how they are pressing to make it airtight. These are the local things which can be done. I have also have a mega project here in IIMR to promote the silage production. And in this, as I have mentioned, then the intercropping is done with the maize. In maize, what we have done, 2 rows of maize we have taken, and 1 row of pearl millet and sweet sorghum. Likewise, we have included the little millets also, in which barnyard millet is there, proso millet, finger millet, and little millet. Why these millets are included in maize? Just to reduce the spoilage and to increase the micronutrient quantity, because these millets, minor millets, are very rich in micronutrients and they have a high buffering capacity. So fluctuation in pH and production of butyric acid will be less. Meanwhile, we have included legumes in 2:2 ratio, means 2 rows of maize at the same spacing and the 2 rows of cowpea in between the maize rows. So what we have found, that the maize intercropped with cowpea is the best combination for making the silage. Because cowpea, maize and cowpea intercropping is such kind of system that maize is benefited by the cowpea and cowpea is benefited by the maize. You will wonder how. Cowpea is a leguminous crop, so it supplies additional nitrogen to the maize, and maize support cowpea because this cowpea is a very lanky crop. It needs something to stand, right? Like in terms of the anchorage. If this cowpea grow on maize, then the formation of this fruit, beans, and it is high. So this is a associated mutual benefit. Maize benefits cowpea and cowpea benefits maize, and they are very compatible crops. They can grow very nicely with each other. And in 2 seasons we have recorded, in spring as well as in Kharif. You notice that we have the fresh biomass yield around 30 ton per hectare, and dry biomass yield around 5 ton per hectare. The purpose of showing this data is to demonstrate that the maize intercropped with cowpea can be used for silage making. So in nutshell, maize is a very suitable option for silage because of its high buffering capacity and plus high carbohydrate content. And legume intercropping improves the silage quality. There is no doubt that the legume supplies the protein and nitrogen into such kind of silage. And silage is the best option for animals during the lean period. Lean period means the period varies from April onwards to June. So silage prepared during this season would enhance the milk production in animal. So with this, I thanks the organizer. And if any query, any questions related to maize, agronomic POP and silage are most welcome.
Thank you, ma'am. If there are any questions, participants can turn on the microphones and they can ask in the. Dr. Dinesh Acharya, please raise your question.
नमस्ते मैडम, ये मेज में कोई मल्टी कट वैरायटी डेवलप हुई है क्या?
मल्टी कट वेराइटी अभी है ना फॉर्डर में